Right, so welcome back. This is part 3 of this assignment. There is 4 parts. Depending on what cohort you are in, you may be assigned part 4 today. You may be assigned part 4 tomorrow after we do a lesson on expected value. Alright, so I'm currently in the second sheet of this file. So sheets are called the tabs at the very bottom. So you can just click to kind of go back and forth between those. If you were to create one of those and you want to rename them, you can click on the arrow and rename. You can move them around, you can duplicate, all that kind of stuff. If you want to see all your sheets in a file, you can select the pancakes over here and it lists them all. If you want to add a sheet, you just select the plus and it adds a sheet as well. You can see in this sheet, there's actually 3 different scenarios that we're going to go through. You're going to do 2 of them, I'm going to do 1 of them for you as a demo. So the 2 that you're going to do is you're going to consider the random variable being the face on a single dice when you roll 1 dice. You're also going to consider the random variable is the difference between the 2 dice, so the subtraction between the 2 values on the 2 dice. And what I'm going to do for you guys to demo is looking at the sum of 2 dice, which we looked at in class as well. I've already set up the distribution for you in terms of the number of ways to get those different values. So my sums go from 2 to 12 because that's what I can get for a sum of 2 dice. Number of ways for me to get a sum of 2, only 1 way, you have to roll snake eyes. Number of ways for me to get 7 was 6. All of these values came from that outcome table that we made in class. All right, I've formatted this table nicely, so a little bit darker at the top with white text. This is a kind of a subtotal that I thought should be a little bit colored and stand out as well, so I did that with a lighter blue color. Everything's centered. I've froze down to here so that my titles won't change, that kind of thing. So next what I'm going to do is I'm going to first calculate the total of my n of x to see what my sample space is. The sample space is, again, all the total number of possible outcomes that are possible. So I just pressed equals because I want it to do a calculation, and then Google Sheets will often predict what it is you're trying to do as well. So it predicted that I wanted to do a sum. That's exactly what I want to do. As soon as I hovered over, it highlighted everything in orange, telling me that's what it wants to find the sum of. Again, that's exactly what I want it to find the sum of. I'm just going to click on that, and it did it itself. Press enter, done. If it didn't do that myself, I would have typed equals sum, selected that particular information. All right. Now I want to create a probability distribution this time, not just a statistical distribution of the raw data, but a probability distribution. So I need to calculate the probabilities. Again, remember, distribution is just showing all the different outcomes. If it's a frequency distribution, it's showing the frequency of all those outcomes. If it's a probability distribution, it's showing the probability of all those different outcomes. It's another one of those big ideas. All right, so to get probability is just number of ways of getting what I want over a number of ways of getting absolutely anything. Number of ways of getting what I want for this particular row, I want to get a 2. How many ways can I get a 2? I can get it 1 way. I could type 1 there. I could go 1 divided by 36, and that would work. But I have to type it in every time. Again, this chart's not very big, so that wouldn't be that cumbersome. But if you had a really big data set and you had a lot of information, typing in the formulas every time is annoying. Plus, if you were to change the values, what if that shouldn't be a 1? What if it should have been a 4? Then I need to change my equation in probability as well. It won't automatically change for me. So instead what I want it to do is I want it to do this cell divided by, just using the / by the question mark, this cell. So H4, orange, divided by H15, purple. I press enter, it did it. Great. Okay, now, look at all those decimal places. I don't need all those decimal places. And that's going to do the same thing for this whole thing here. So I'm just going to go down like this. And if I do that, that's to the nearest 10th of a percent, right? I didn't multiply by 100, we can just leave it as a decimal. And that's fine. Okay, so now I'm going to teach you a new kind of thing that Google Sheets can do, as well as other spreadsheet software. I actually want to copy that formula down. I want to fill it down is what it's called. So if I go over here, when I'm selected on this cell, in the bottom right corner, there's this little box. If I move my cursor onto that box, see how it changes into a plus sign? That plus sign is what I want. As soon as that happens, I want to click and hold, and then I want to, sorry, I can't click and hold for that long, or my computer tries to look up the definition for me. I want to click and hold and drag. Uh-oh. So it just gave me an error. What is that error? That's no good. If I hover over, the comment tells me error function divided by 0. That's not good. Okay. The reason I knew there was a comment is because in the top corner, there's that little red kind of triangle. That tells me there's a comment on there. So if I ever leave comments for you, you'll see those little triangles. If you just hover over, the comment will pop up. Okay, but that's not good. We don't want that. So let's click on one of these and try and figure out what's going on. What's this purple thing? So you can see down here, now I'm selecting here. I'm trying to divide by that. I don't want to divide by that. I want to divide by this. What happened was I copied this cell. I filled it down twice. So orange shifted twice. Purple shifted twice. Huh. I wanted orange to shift. That's good. I did not want purple to shift. So we're going to do something called locking something in. I don't know. I think it's absolute reference. Technically, it's the technical term, but I just say I'm locking it in. I want to lock in that this 36 comes from 15, row 15. So in order to do that, in front of the 15, I'm going to put a $sign. $sign means I'm absolute referencing. I'm locking in that 15. Now when I drag it down, that 15 will not change. I could do the same thing for the column. I could lock it to H, but I'm not actually shifting left or right, so I don't need to do that, but I could. Now when I go here to the little box, click and drag, that all makes way more sense. We can double check. Double click on that. Orange divided by purple. Awesome possum, we got it. Okay, I also want the sum here. I am going to drag this one across. So I just selected on the corner here. Click and drag across. That sum is 1, 100%. Perfect. That's what I wanted it to be. If it wasn't, something went horribly wrong, we would have had to fix it. That's okay. Things go horribly wrong all the time. All right. So that is my probability distribution table. Now I want a probability distribution graph. Now, my random variable x was the sum. I cannot get a sum of 3.7. So this is discrete data. And it's not over a really long range, so I don't have to treat it like continuous. I'm going to treat it like it's discrete. I want to graph this. So I'm going to select everything. I am not selecting my totals. That doesn't make sense. I don't want to graph that. I'm going to go Insert, Chart. Okay, so it's guessed wrong again. It guessed histogram. It's not continuous, so I do not want a histogram. What I want is a bar graph. Column chart. I do want a column chart. So let's click on that. Yes, that's what I want. So they call a bar graph a column chart. It kind of makes sense. Columns are vertical. But you will notice that I have blue and red here. The blue is my number of ways, my cardinality of that particular set. But I don't want number of ways to get x on this graph at all. I only want to see the probability. I want a probability distribution. All right. Looking at my chart editor, you can see that the series is like the particular set that you're graphing, the particular thing that you're graphing. So you can see that I'm graphing n of x and I'm graphing p of x. I don't want to graph n of x, so I'm going to go over to the Timbits, the 3 dots, and I'm going to say remove. She gone. Bye-bye. So now we just have the 1. That's good. Let's clean this up. So this is probability distribution of the sum of 2 dice. Awesome. This is the sum of 2 dice. That looks great. Over here, again, I can't just double click and edit because they didn't give me one to begin with, which is ridiculous. Come on, Google Sheets. I'm going to go to chart and axis titles. I'm going to go to vertical. And I'm going to say, I'm not going to say frequency this time. That's what it wants me to do. But that's not frequencies. That's probabilities. Probability. There we go. All right. So now when I'm describing this graph, again, like I was talking about before, the key things that I want you to look for are the overall shape. So in this graph, I can start to talk about whether or not it's uniform. Uniform would mean everything had the exact same probability. Well, you can see getting a 2 is way less probable than getting a 7, so it's not uniform. So we start to ask ourselves, okay, is it symmetric or non-symmetric? This is symmetric, right? It goes up and it goes back down. Now, when you use language like that, it goes up and it goes back down, it kind of infers that something's changing. These are completely different situations. So we want to kind of change the grammar. So instead I want to say low sums have low probability. High sums also have low probability. Middle sums has high probability. So kind of like separate it out into different sums rather than kind of as something changes. So if I were to describe this distribution, I would say this is a symmetrical distribution. The sum of 7 is the most likely to occur because it has the most number of ways for it to happen. And then as you get farther and farther away from a sum of 7, you end up getting less and less ways for that to happen. Therefore, there are less and less probable sums, and that ends up being symmetric in terms of how that occurs. Okay, so your task to finish up part 3 is to create a probability distribution table for single dice, and for 2 dice rolls, the difference between the 2 dice rolls. You're going to create a bar graph distribution for both of those, and then underneath, you're going to combine a whole bunch of cells together. Maybe you want to do it as 3 separate, and you are going to describe the distributions. So I've actually already done that one, you're just typing it out. But you're going to describe the other 2 distributions as well. And that is the end of part 3. If you were in cohort A, that's it for today. If you're in cohort B, there is a part 4. Cohort A, you'll be doing the part 4 tomorrow after we do it in class.